Hello friends, welcome to the ninth video of Mentor-Mentee Internship Program. This program is initiated by the team Write a Prize. Myself Priya Singh, the mentee for this program, and the mentor Varshika Chaudhary is guiding me for the technology Python. So, this is the ninth lecture of the Python technology. In this lecture, we will study about the left top types of operators. So we have already seen in lecture 8 what the operators are. So the left types of operators which we have not discussed are logical operators, bitwise operators, membership operators and identity operators. We will see these four one by one. Also again in this note that A is assigned as 10 and B as 20 wherever they are not specified. Firstly, we will start with pathological operators. Here are the three basic types of Python logical operators that are logical AND, logical OR, and logical NOT. Logical AND, if both the operands are true, then condition becomes true. Means for A and B, if both the conditions are satisfied, then only the result will be true. Otherwise, it will be false. For example, A is assigned with 10 and B is assigned with 20. If it is asked that A is greater than 30 and B is greater than 30, since both the statement is false, so it will return false statement. But if A is smaller than A is smaller than 30 and B is smaller than 30. If this statement is passed, then it is true. So it will return a true statement. Logical OR. If any of the two operands are non-zero, then condition becomes true. Means this statement returns false only when both the operands are gives the condition false. Otherwise, it will always return the true statement. That is, if A is greater than 5 and B is smaller than 5. Since the condition for B is false, but still the result will be true since the statement of condition for A is true. Now the logical NOT. Used to reverse the logical state of its operand. Means not A and B is false. Means if for A and B, we have seen that A and B, it is true. So if we are keeping here that not A and B, then it will reverse this statement and will return the false statement. Okay. Now we will see Python bitwise operators. Here let A is equals to 60 and B is equals to 13. Then in binary format they will be as follows. A is equals to 00111100 and B is equals to 00001101. Now we will discuss about the bitwise operator by following these two variables which is initialized with 60 and 13 and their binary format is given as this. So firstly comes the binary AND. Operator copies a bit to the result if it exists in both operands. Means it returns true value only when both the values are true. Means for 0 1 it will return 0. For 0 0 again it will return 0. Okay, for 1 0 also it will return 0. But it will return 1 only when both the values are 1. Okay. Therefore A and B means 00001100. Okay. Then comes binary OR operator. It copies a bit if it exists in either operand. Means if any of one of the values is 1, then it will copy the value 1 in A or B. Here with an example we can see that 0 1 copies 1. Okay, 1 1 copies 1. Here 1 0 also copies 1. But for 0 0 only it copies 0. So it copies a bit if it exists in either operand. So A or B is equals to 61 means 00111101. Then comes binary XOR. It copies the bit if it is set in one operand but not in both. Means it copies only when here it is 0 1, so it copies 1. Here it is 0 0, so it copies 0. Means whenever both the values are same, it does not copies. Whenever the values are opposite, it copies as 1. Okay. So A or B gives 49, and here is its decimal representation. Binary ones complement. It is unary and has the effect of flipping bits. Unary means it needs only one operand, and the effect of flipping bits means it just reverses the digits. Like in A we have 0 0 1 1 1 1 0 0. Then for binary ones complement we have 1 1 0 0 0 0 1 1. Means just reverse. If it is false, it will be true. It is 0, it will be 1. Okay, then comes binary left shift. The left operand's value is moved left by the number of bits specified by the right operand. See, the right operand specifies 2 bit shift of the value in A. So here we have A as 0 0 1 1 1 1 0 0. It will shift 2 bits left side. That is here it will shift 0 and then again 0, then the value will come 1 1 1 1 0 0. Since it should be a 8 bit, then the left space is given the value 0 and 0. So we come with this 240 and this binary representation. Then comes the binary right shift. The left operand's value is moved right by the number of bits specified by the operand. Okay, by the right operand. So here for A and this right shift 2, we get the value this. Why? Because let's see here it is A. Okay, and we have to shift 2 bits right side. Means 1 will come here, then this one will here, then 1 1, then 0 0, and here the 2 empty values will be set as 0 0, as we have seen in binary left shift. Now comes the Python membership operators. Python's membership operator tests for membership in a sequence such as strings, lists, or tuples. There are 2 membership operators. They are in and not in. The operator in evaluates to true if it finds a variable in the specified sequence and false otherwise. Means if the value is present in the another value which we have specified, then it will result in a 1. If it is not present, then it will result in a false, that is 0. So here we can see x in y. Here it results in a 1 if x is a member of sequence y, otherwise a 0 result. Okay. Then comes a not in operator. It evaluates to true if it does not find a variable in the specified sequence and false otherwise. Means it is just opposite to the in operator, that is x not in y. Here not in results in a 1. Means we can see that x is not in y. Like we can take an example that Ram is in Rameshwaram. So that Ram is a substring of Rameshwaram. So if we will use not in, so it will result in 0, as there Ram exists in that substring. So and if it does not exist in that, then it will return a 1. Comes the Python identity operators. Python identity operators compare the memory locations of 2 objects. As we have seen before in Python membership operators, they compare substring and a string or variables, but here the memory location of 2 objects are compared. There are basically 2 identity operators. They are is and is not. Is evaluates to true if the variable on the either side of the operator point to the same object and false otherwise. That is x is y. Here is results in 1 if id x equals id y. Means if both the memory locations are equal, then the result is 1, otherwise false. Is not evaluates to false if the variables on either side of the operator point to the same object and true otherwise. X is not in y. Here is not results in 1 if id x is not equal to id y. Means if these both equations are not equal, then the result will be 1. Otherwise, it will be 0. Thanks for watching the video. Please watch our video lecture 10 to cover the further topics.